Did you know there's an entire continent hidden beneath the ocean? One that challenges everything we thought we knew about Earth's geography? This astonishing revelation emerged in 2016 when scientists discovered Zealandia, a submerged landmass that redefines the boundaries of exploration. For centuries, we've confidently identified 7 continents. But now Zealandia raises the possibility that Earth has been hiding an 8th, silently lying beneath the waves, waiting for its story to be told. Chapter 1. Introduction of an 8th continent. Zealandia's journey to recognition began when geologists started investigating anomalies in the Earth's crust beneath the South Pacific Ocean. Unlike typical oceanic crust, which is thinner and denser, the crust here resembled that of the continents, thicker and composed of lighter materials like granite. Stretching over a vast area of approximately 4.9 million square kilometers, this hidden landmass was not just a fragment of something larger. It was a contender for full-fledged continental status. What makes Zealandia unique isn't just its size or structure, but its history. Scientists believe it was once part of the ancient supercontinent Gondwana, which existed over 200 million years ago. Gondwana included modern-day South America, Africa, Antarctica, Australia, and India. Around 80 million years ago, tectonic forces began to pull Gondwana apart, and Zealandia broke away. Unlike other fragments that remained above water, Zealandia's crust was stretched and thinned, causing it to sink beneath the ocean's surface over millions of years. Although submerged, Zealandia's legacy remains visible. Islands such as New Zealand and New Caledonia are its highest peaks, standing as remnants of this lost continent. This underwater continent is not just a geological curiosity. It provides insights into the tectonic activity that shaped our planet. The discovery of Zealandia invites us to reconsider what we know about Earth's surface, its evolution, and how continents are defined. The scientific significance of Zealandia extends beyond mere classification. It provides a unique opportunity to study plate tectonics, the process by which Earth's crust is constantly reshaped. The forces that submerge Zealandia could have implications for understanding earthquakes, volcanic activity, and the movement of continental plates in this dynamic region of the world. This newfound continent is more than just a submerged landmass. It's a symbol of how much we still have to learn about our planet. Zealandia challenges our assumptions and reminds us of the mysteries that lie beneath the surface, hidden yet essential to understanding the Earth's past and future. Chapter 2. Criteria for continents. What truly defines a continent? Is it merely the land we can see, or does it go deeper, into the very fabric of Earth's geological structure? To understand why Zealandia is being considered a continent, we must examine the specific criteria that classify landmasses. The first criterion is the presence of continental crust. Unlike oceanic crust, which forms most of the seabed, continental crust is thicker and composed of less dense materials such as granite. This makes it buoyant, allowing it to sit higher on Earth's mantle. Zealandia meets this criterion unequivocally. Detailed studies have shown that its crust shares the same properties as those of the 7 recognized continents, making it distinct from the surrounding ocean floor. This alone places Zealandia on a strong footing in the quest for continental status. Size is another defining factor. To qualify as a continent, a landmass must cover a minimum area of 3 million square kilometers. Zealandia exceeds this threshold significantly, stretching across an estimated 4.9 million square kilometers. Its vast size is not immediately apparent because 94% of it lies underwater, but advanced mapping techniques have revealed its true dimensions. In terms of surface area, Zealandia is larger than some well-known continents like Europe. The third and final criterion is separation by oceanic crust. A continent must be distinct from others, with clear boundaries defined by the surrounding oceanic crust. Zealandia achieves this separation. It is geographically isolated, lying east of Australia and separated by the Tasman Sea. This isolation is the result of tectonic forces that tore Zealandia away from Gondwana millions of years ago. These 3 criteria, continental crust, sufficient size, and clear separation, are the foundation for defining a continent. Zealandia ticks all the boxes, yet its recognition is complicated by its submerged nature. While its underwater status makes it less apparent, it does not diminish its geological significance. The rigorous application of these criteria demonstrates that continents are not merely a collection of visible landmasses. They are defined by their composition, size, and geological independence. Zealandia, despite being hidden beneath the ocean, meets these qualifications, challenging our traditional understanding of what constitutes a continent. Chapter 3. Beliefs about the past. Did explorers from long ago already know that some continents were hidden? Scholars and sailors in Europe thought there might be a huge landmass in the south a long time before Zealandia was actually found. People thought that this imaginary continent, Terra Australis, would balance out the landmasses in the northern hemisphere. Even though it was made up and not based on facts, the idea had a big impact on travel during the Age of Discovery. During the classical and medieval periods, the idea of Terra Australis grew out of the view that the Earth needed to be balanced. Geographers and cartographers from the past thought that this huge southern land would keep the known continents in balance. These ideas showed up on early world maps. They didn't have any scientific support, but they made people want to learn more and explore. When the Dutch sailor Abel Tasman set sail in 1642, the question grew. He was given the job of mapping out unknown areas and accidentally found what we now call New Zealand. It seemed like Tasman and his team had found a piece of Terra Australis at the time. Even though this finding was huge, it made things even more confusing. Tasman's maps showed New Zealand as the edge of a much bigger island, which fed the idea that there was a huge southern continent. But the truth about Terra Australis remained hidden. Tasman made maps of some of New Zealand's coast, but he didn't go inland to explore. His mission had to turn back because the land was too rough and they ran into hostile Maori people. This lack of knowledge left room for guesses, which led to stories about what lay beyond. People still believed in Terra Australis well into the 18th century. Even after Captain James Cook's trip showed that there wasn't a huge southern continent, people still thought there was one. Cook's exploration of New Zealand made its geography even clearer by showing that it is made up of islands and not a piece of a bigger landmass. It's interesting that these early ideas helped pave the way for the final discovery of Zealandia. Even though Terra Australis was just a story, it showed how curious and determined people are to learn about the unknown. When Zealandia was found many centuries later, it was a surprise. It proved scientifically that people had believed in hidden places for a long time. Chapter 4. A timeline of scientific discoveries. How did Zealandia go from being a myth to being a science fact? There were important findings that led to its recognition as a continent, beginning in the 19th century and ending in the 20th. It was in 1895 that the famous scientist Sir James Hector made an important discovery. He found a continental edge while studying the geology of the water around New Zealand. Unlike the oceanic crust around it, this shelf showed signs of a much larger landmass that had been buried over time. Hector said that New Zealand was just the tip of this continent that had sunk. Even though his ideas were ahead of their time, they didn't have the right tools or information to become widely shared. In 1995, geophysicist Bruce Lewandijk came up with the name Zealandia to describe this underwater area. His work added to what had already been seen by using new techniques in oceanography, seismic surveys, and satellite images. Lewandijk's study strongly suggested that Zealandia was different from the ocean floor around it and had features similar to continental crust. Just the name Zealandia meant a new age of exploration. It changed the focus from theories and stories to facts that can be measured. People became very interested in Lewandijk's findings, which led to more geological study being done in the area. Scientists did a lot of research over the next 20 years, mapping Zealandia's edges and studying its rock. The development of advanced imaging methods was one of the most important steps forward. Scientists were able to see how big Zealandia really is by using earthquake data and satellite mapping. With these tools, scientists were able to find a large body of water covering more than 4.9 million square kilometers, which is bigger than India. But it was still debated whether Zealandia should officially be called a continent. Even though the geological proof was strong, scientists disagreed on whether the fact that it was underwater meant it wasn't a continent. In any case, the finding was a big step toward understanding the hidden geography of Earth. The time it took to find Zealandia shows how our ideas about our planet have changed. From early hypotheses to current technology, the journey shows how important it is to keep looking into things in science. It also shows how knowledge changes over time, with myths being replaced by proof and the limits of what can be found constantly growing. Chapter 5. Latest research and evidence. How did Zealandia go from being a geological wonder to being a real continent? Research and technology progress at the cutting edge led to this huge change. Scientists used rock samples, satellite mapping, and geological surveys to prove that Zealandia is a separate continental crust. This changed the way we think about Earth's geography forever. Geological tools have changed a lot in the last few decades, making it easier to study land masses that are underwater. Rock sampling led to one of the most important breakthroughs. Researchers were able to get samples of continental crust by digging into the ocean floor around New Zealand and nearby areas. These rocks, which are different from the basaltic rocks that make up the marine crust, proved beyond a doubt that Zealandia was not just an extension of the ocean floor. The rock's unique chemical makeup and age were in line with what you'd expect to find in continental landmasses. Satellite mapping was also very important in revealing Zealandia's true size. Scientists were able to see the shape of this huge island under the water using high-resolution imaging. With an area of almost 4.9 million square kilometers, Zealandia was a region bigger than India, but 94% of its surface was still underwater. These detailed maps not only showed where Zealandia's borders were, but they also showed its geological features, like mountain ranges and sedimentary areas, which were similar to those on other continents. Geological studies made the case for Zealandia's continental position even stronger. International teams studied it and found that its crust was thicker and less dense than the marine crust around it. This is one of the most important qualities of a continent. These surveys also found tectonic action in the area, which suggests that Zealandia used to be a part of the supercontinent Gondwana, but broke away and sank over millions of years. The effects of these results were very big. Zealandia changed the world map and questioned what people usually think of as a continent. It proved that continents could live mostly underwater, which led to new study and exploration opportunities. For experts, the find made it clear how important it is to look again at Earth's hidden geography. The discovery of Zealandia was not only a scientific success, but also a sign of how curious and creative people can be. With careful study and cutting-edge technology, what started out as a vague idea turned into a major discovery that changed the way we think about the structure of the Earth. Chapter 6. Legal Implications. What does the fact that Zealandia has been recognized mean for politics around the world and claims to land? In addition to being important for science, Zealandia's position as a continent has major legal and economic effects, especially for New Zealand. According to the United Nations Convention on the Law of the Sea, UNCLOS, countries can claim more land based on continental shelves. In this situation, New Zealand had a reason to prove that Zealandia was a continent. If Zealandia is recognized, it could make New Zealand's exclusive economic zone, EEZ, almost 6 times bigger, giving the country rights to sea resources that have never been seen before. A very careful legal and scientific method was needed to prove Zealandia's status. Geological data was very important because New Zealand had to show that the underwater landmass was a part of its continental shelf. The country gave the United Nations a lot of information, such as rock samples and seismic readings. These papers explain Zealandia's borders, its geological traits, and how it is connected to the rest of New Zealand's landmass. The possible benefits were huge. By expanding its EEZ, New Zealand would be able to use all of the natural resources in this area without anyone else being able to. This includes being able to fish, find minerals, and possibly find oil and gas reserves below the ocean surface. Such resources could greatly improve the country's income, which makes Zealandia an important place for both science and business. However, recognizing Zealandia also brought new problems. When countries claim more land, they often get into fights with nearby countries, especially where maritime borders overlap. New Zealand had to be very careful in these diplomatic waters and make sure that its claims were based on strong proof and followed all international laws. Zealandia has law effects that go beyond New Zealand. The fact that it was recognized sets a standard for other underwater landmasses around the world. Now, countries with similar geological traits may try to expand their EEZs, which could change the shape of the world's maritime borders. This event shows how the connection between science and geopolitics is changing. What scientists find under the water can have an effect on economic and diplomatic plans between countries. Finally, the discovery of Zealandia as a continent is more than just a big step forward in science. It is also a big deal in the legal and business worlds. It provides New Zealand with a way to get more supplies and power. For the world, it shows how secret geography has a huge effect on world politics. Chapter 7. Continental Ambiguities. What truly defines a continent? This question has puzzled geographers, scientists, and historians for centuries, and the recognition of Zealandia has only intensified the debate. The definition of a continent has always been fluid, shaped by cultural, geographical, and scientific interpretations. While most people grow up learning about 7 continents, the actual criteria behind this classification are far more complex. Historically, continents were often defined based on visible landmasses, cultural divides, or arbitrary boundaries rather than strict geological criteria. For example, Europe and Asia are technically part of the same massive landmass, yet they are treated as separate continents due to cultural and historical distinctions. Similarly, Antarctica was long considered a myth until explorers confirmed its existence in the early 19th century. These examples highlight the evolving nature of our understanding of Earth's geography. The discovery of Zealandia has further blurred the lines of these classifications. Unlike traditional continents, Zealandia is almost entirely submerged, with only a few land masses like New Zealand rising above the ocean. This challenges the long-held assumption that continents must be predominantly above water to qualify. Scientists now argue that continental status should be based on geological features rather than visibility. Cultural interpretations add another layer of ambiguity. In some parts of the world, the idea of a continent is tied to political or social factors. For instance, Australians often consider Oceania as a single entity encompassing Australia, New Zealand, and numerous Pacific islands. Adding Zealandia to the mix complicates this regional framework, raising questions about its place in global maps and educational systems. Geographical models also vary. Some maps depict Eurasia as a single continent, while others split it into Europe and Asia. Similarly, North and South America are sometimes combined into the singular Americas. These inconsistencies highlight the subjectivity involved in defining continents, making Zealandia's recognition an even more significant challenge. The ambiguity surrounding Zealandia underscores a broader issue: the need for a unified, scientifically grounded definition of continents. As our understanding of Earth's geology evolves, so too must our classifications. Zealandia's case pushes us to rethink traditional models, emphasizing the importance of geological evidence over arbitrary distinctions. In doing so, it opens the door to a more nuanced and accurate representation of our planet. Chapter 8. Geological Characteristics. What sets Zealandia apart from the surrounding ocean floor? While this submerged landmass remains hidden beneath the waves, its geological characteristics reveal it to be far more than just another patch of seabed. Zealandia's unique structure and composition make it geologically distinct, resembling other continents despite its underwater location. One of the most striking features of Zealandia is its crust. Unlike the dense basaltic crust found on the ocean floor, Zealandia's crust is much thinner and less dense. This type of crust, known as continental crust, is typically found in continents like Asia or Africa. The composition of Zealandia's crust includes lighter materials such as granite, further differentiating it from the surrounding oceanic crust. Zealandia's topography is another distinguishing factor. While most of the continent lies submerged, its depths are relatively shallow compared to the abyssal plains of the ocean. On average, Zealandia lies about 1,000 to 2,000 meters below sea level, significantly higher than the typical ocean floor, which plunges to depths of over 4,000 meters. This shallow depth hints at its continental origins, as does its geological history, which includes episodes of rifting, subduction, and mountain building similar to those seen in other continents. The boundaries of Zealandia are also clearly defined. Using advanced seismic imaging and satellite data, scientists have mapped its extent, revealing a landmass stretching over 4.9 million square kilometers. These boundaries are marked by a sharp contrast between Zealandia's continental crust and the denser oceanic crust that surround it. Such well-defined borders are a hallmark of continental geology, further solidifying Zealandia's claim to continental status. In addition to its crust and topography, Zealandia's geological history provides further evidence of its uniqueness. Share this journey with others and subscribe to stay updated on the latest discoveries about this mysterious of the world. Together, let's explore the unknown and redefine our understanding of the world.